Hello, today I'm going to show you how to CAD airfoils. We're going to show two different methods and in both NX and SolidWorks. So let's get right into it. Pretty interesting stuff. So first, I'm going to delete this search. Okay, first let's go to airfoiltools.com. This is where you can get your data from the airfoil. There are lots of good airfoils on Airfoil tools, but not every airfoil is here. Example of this is the benzene profiles. You'll need to get this information and CAD it. And one of the ways to CAD airfoils won't be available to you if you decide to CAD these airfoils. Now, let's just get right into it. What's the first method? I'm sure it's the easier method. Let's just find an airfoil. I'm going to go with the NACA 4412. Essentially, I'm going to speed run this. So we're going to go here, send to airfoil plotter. We'll just click it. Chord length 10. Don't worry about the millimeters. It'll be whatever units that you use in your CAD program. Now right click, open link new tab, will download a file. Yes, it will download a file if I can. Where is the file? There it is. Drop this in here. It's going to be an Excel file. We're going to click on it. Essentially, we want coordinates of points. We want the point coordinates. So we're going to take all of these point coordinates, put them on the top, and get rid of the camber line. We don't need that garbage. Okay. And finally, we're going to add a z coordinate. And then we're going to file, save as. This is the important one. Text, tab delimited, hit save. Now, let's move on to NX. And we're just going to make a new file. I'm going to put it in the right directory that we are using. And we are going to call it NACA 4412. And essentially, we're going to go File, Import, once you file, it will start an ASCII. You need to go to Text or All. Put the NACA, I have another airfoil in there. Essentially, you get this. Now we have a bunch of points we don't have really CAD. We need to connect these points in a continuous curve. How we do that is fit curve right here. Now this tool itself will not be here. I put it here. You'll need to go search for it, and you will need to right click and add a top order bar if you want it right here. It's essential to have on hand if you're going to be CADing airfoils a lot. Now, notice that this airfoil has an open end. Some will have a closed end, and it will be very easy. Just use this tool once, and you'll have an extrudable airfoil. We will actually need to close this airfoil with a sketch. Now, let's just start selecting points. You can select points like this, but you can also mass select points. But you can also mess up mass selecting points. You don't want to do that. Shift and deselect all these. Be careful when you get here, because if I know that this airfoil includes a point at the origin, so I'm going to select the origin. Some won't, and if you accidentally select the origin, you won't have the correct airfoil, or something bad will happen. But yeah, pretty much just select all of these. Select, that was wrong. Shift, deselect, very easy, and then we'll select this last point. And essentially you want this number to highest as possible until it tells you error. Okay. The more data, the higher the amount of segments. Now to finally cap this off, if you can't extrude this, you're going to want to go to Sketch, Simple Sketch Stuff, Advanced Settings, of course, and then you're going to want to go, because you're very proper, you're going to want to go to Project Curve, and project these 2 points, and you want to hide the point because you like that. And then you want to connect the 2 points with either a line directly or 2 tangent lines. I'm going to do a right line directly just for this example. It shouldn't matter. CFD may not like this line at the end, but it doesn't really matter. We're going to select both, and we'll hit extrude, It's going to load for a bit and be confused, and your computer can heat up for a bit. Eventually, you have an airfoil. Now, one of the common problems in NX with this method is if you choose a really large chord in Airfoil plotter, you can have the viewing be very weird. So like this, let's say I have to put 50 in here. The viewing gets really weird around here. And this can happen with points. Your points will fade in and out, and it'll be really weird. So right click, fit, solves all the problems with viewing. But let's go back to 5. So this is great. This is great. You will need to get this, if you want this bigger or smaller, you'll need to scale it. But there's another method that I believe is superior, and I will show you that method now. Let me delete these and the geometry. Now, let's get right into that method. We don't need that. What we do need is a screenshot of the NACA. There we go. And we're going to save that in the correct directory. As give it a name. I got rid of that. Now what we're going to do is we're going to file. Actually, no, we're going to go to Tools, Raster Image. Actually, before that, make a sketch. You're going to want to make a sketch. This method will take a bit longer, but I believe it is superior. So draw a simple horizontal line, make it a construction line, make it a 1-inch line, or whatever units you're using. Now you're going to go import that image. I'm going to go find that image first. Go to, is there an all files? No, there isn't all files. PNG. Now you have your image, select a plane to put the image on. Now you want to insert the leading edge on the origin, so you want to use a user-defined insertion point. And select the leading edge, of course. There you go. Now it's asking for a second point on image. That's obviously the trailing edge. And that's the point on model. Now that's that line you drew earlier. It has an end. Boom. Now you have a perfect image. Now you're ready to CAD the actual airfoil itself, which is a little bit difficult, but you will get the hang of it. And it is essentially a much superior way to CAD airfoils. So right now, the tool I'll be using in the sketch mode is also called Fit Curve. It's different than the other Fit Curve. Once again, search it, top border bar, in the sketch command. It's within sketch, it works. It works great. Now, firstly, we want to draw this camber line. It's very important that we draw the camber line to get the correct symmetry or the correct geometry of the airfoil. I mean, it's kind of important. It's not important. Never mind. It's very important. So, 3 segments. That means you need 4 points. 1, 2, that's 4. You'll want one at the leading edge. You'll want one at the trailing edge. Now, I'm going to choose to make this a flat end. Sorry, a pointed end. If you want to make a flat end, you could take a line, attach the middle to there, and then just go at it, follow the rest of what I'm telling you to do. But I want a pointed end because I just find that to be better. So I'm making a construction, and I'll take these 2 poles, and essentially I'm going to make them so that this line, this line matches the camber line. Now the important part is you match the leading edge, let's say that matches, and the trailing edge as much as the middle, because it's very important for constraints and dimensioning reasons. Now this is perfectly fine. We have right now, and make it into a construction line. Now I'm going to draw 3 separate lines. I'm going to make these all construction. And then I'm going to place, that is not what I want to do at all. I'm going to place these lines as these lines out here, the lines that constrain the fit curve. I'm just going to place these lines. There we go, and now we have 3 lines. Life is good. Now, first we need to dimension everything. What I like to do always first, dimension the angular constraint, and the reason we do those lines at all is so that we can actually select them as angular constraints, and constraints in general. You cannot select the points of fit curve, or the lines of fit curve, as I just did. So you will need to put in those lines, even though it is, yeah, you will need the lines. For other reasons too, very important reasons. Now, we want to dimension everything else, so we're going to dimension this back point first. We have an angle, we have a, let me get out of point to point. Let me get into it further. We have this, so 0.37. And then we want to dimension this front point. It's in a pretty good spot. 0.037. We want to just constrain this to the same place it was. Yeah, life is good. So this is fully constrained. This center line isn't moving anywhere. I'm just going to hide it, and actually I'm going to hide these two, because these are just in the way. But essentially now we have these 3 lines. Now why it's important that we match the amber line in the front and the back is because of this. We're going to draw lines to constrain the actual fit curves you will put on the actual airfoil itself. So we want this line to be like that. We want perpendicular on the line, perpendicular, and perpendicular. And then yeah. Now you may be wondering, what am I doing right now? I'm about to show you. So let's go to this. We're about to 5 degrees. 1, 2, 3, 4, 5. 5 degrees. And we're just going to go this. It will not look right, but it will eventually. We're just going to get these and do each of these points. All these construction lines are used for dimensioning and making sure we have the correct airfoil. So here we go. Essentially why this is if you zoom in, it's a 90 degree from this point, because you want the airfoil to be continuous and correct. Essentially you will just move all these to essentially get the right airfoil. Eventually you'll just kind of massage it up a bit, and that doesn't look right. Well, then again, this is a horrible draw. It's not even that. That honestly looks pretty good. I'm going to say that's pretty good, and we're going to call it at that. Now, next thing you do, you want to do dimensions. So, first thing will be angle dimension this and this. Well, as you can see, I can't select that. Like I said before, you need to add in a line, make it a construction line, match it to here, match it to there. I think it's matched. Yeah. Yeah. Okay, life is good. Now, angular dimension, this to that. That's 7.5, approximately. Let's just bring that back here out of my way. Now just dimension everything else. Rapid dimension. Point to point is extremely useful at this point. Bring all these dimensions out. You can make them less large numbers if you want. You can simplify. I'm not going to for the purposes of this tutorial. You probably should. I always do when I'm actually CADing airfoils. For real. So just dimension everything out and then get out of the way, man. There we go. Oh yeah, you can't do that. Get rid of this one. Because you have the angular dimension at the end. Very important angular dimension. But essentially, everything is constrained. It looks almost right. You can make it look better than this. I'm just showing you the way. When you look at my actual CAD airfoil I put time and effort into, it looks much better than this. But enough of that. Essentially, what you have here is the airfoil. And the dimension is fully dimensioned out. Now, all I have to do is essentially do the same thing for the bottom. Take this. Where's my lock? Okay, I'll just. make these perpendicular, and then make a bunch of lines off of this line. You don't have to, you can choose to do this front line here too, or this back line for a few of these. It doesn't really matter. Essentially, you're using the lines off the camber line to dimension everything. Now draw another fit curve, 5 degrees. And just connect points. As you can see, having these two lines be perpendicular to this line ensures a nice, clean, smooth leading edge. Very important that we have the camber line be correct, and that is essentially why. If it wasn't correct, that wouldn't look nice and smooth. Just how it is. Now, that there, and essentially what you're going to do, once again, you need this line. Don't be like that. You need this line, you need to be construction line, attach it there, attach it at the end, and then angular dimension should be your first dimension. And this time we know the dimension, it should be 7.5 if that was a true camber line. And it's right there. I would say the only reason it's off is because we wanted a pointed end, but yeah, essentially now we have our stuff. We just need to CAD or mention out the rest of it. This might be a little tough to do. You might need to do that and bring it in like that. Yeah. I don't know what's happening there. What is this horizontal constraint? Let's get rid of that. But essentially, yeah, it actually might be greater than 8.5. I didn't do a perfect camber line this time, but let's just, yeah, that works. So now, this is pretty good. I'm sure you can make it better. Okay, there we go. That's what I'm talking about. That's nice, and on that line. Now, once again, dimension everything. Be in point to point. Probably simplify these numbers. Essentially, I'm just going to draw a bunch of constraints, dimensions, and and you might be thinking, there's no way this is a superior method to do airfoils. It takes so long, now, it takes so long. That's the main reason. But now you have a fully, your airfoil is essentially done at this point. It's not really done, but you can extrude it and you get stuff. Life is good. Now, here's the thing. You can maximize your CAD program, and you can do this in SolidWorks as well, with expressions. Control E, make one called chord. Formula is 1, fly. Now, go into your sketch. Essentially multiply every single dimension by chord. Of course, that's 1, we don't need to run it. But essentially, boom, and then just go around and do every single length dimension. And now I think we've done it. Every single dimension, I'm doing a quick check. Looks correct to me. Now what you can do is go to this use expressions and change this. Make it bigger, make it smaller. Essentially what you can do with this is, once you've CAD'd the airfoil, this will be used for any scenario. You can just copy this sketch in, change the user expression. It's just quick like that. Really fast. And I guess we'll move on to SolidWorks now. So now we are on to SolidWorks. So I'm going to show you how to do the two methods of CADing airfoils inside SolidWorks. So here we are with our part. We're going to go to Insert, Curve through XYZ points, Browse, switch to text file, and select the text file, and it will make our airfoil. Nope, don't do that. Okay. Now, even if this is a pointed end, you won't be able to extrude this right off the bat. You will need to come to the front plane. You'll need to draw a sketch. you will need to convert entities. Let me convert the entities. Yes, convert the entities. And then you will close it however you want, either by a line or two tangent lines. I'm going to do a line. That was not done correctly. There we go. And then you can exit. And then you can extrude. Whatever you'd like. We had 5 last time? Let's go 5. That is, of course, one way. It's pretty simple. You don't have to actually connect the points. But, yeah, that's that first way. I'm going to now delete the rest of it, and I'm going to show you how to do, yes, the other way. First, come to the front plane, just like we did in NX, sketch. This is the origin. Create that 1-inch line. Where's construction? There it is. And then 1-inch. Exit. And essentially you do the, actually you stay in the sketch, my bad. Let me go edit sketch. Stay in the sketch. You want to go to insert, no, tools, sketch tools, sketch picture, and you're going to insert the PNG. And this time you get a lot more, I guess, freedom over where you put the PNG. You just got to put it essentially in the right place. Just make it smaller. And it's not really all that concerned with all those insertion, just line it up correctly. Take a bit of time, but that's just how it is. Let me put that right there. And now, of course, you can get to be more exact. That's pretty much it. You just line up the sketch, and we're going to hit that check button. And then you're going to spline the camber line and spline the core line. Now, let me exit here. Okay, well, we can't see it anymore. There it is. One thing to note about this is the expressions. For the expressions, we can go to tools, go to equations. We will still have our chord and we will have our value equation. So let's go and do that. Value is 1-inch. Okay. One thing to note, and let's go into the sketch again. Edit the sketch. If we just write down chord, it will change it to 1-inch, and when we edit the actual expression, it won't change. You need to do equal sign chord and have that, and there, when you do that, you have this equal sign. It will change the line based on this right here. Now, another thing to note in SolidWorks, when you copy over the sketch to whatever you're going to want to do to have the same thing, when you copy over the sketch, it will not copy over the equation for you. I suggest you change it to whatever chord you want and then copy the entire sketch over. And I guess that was it for SolidWorks, and thank you for watching.